अब स्टूडेंट्स, जैसा कि मैंने आपको बताया, ईथरनेट इज इनहेरेंटली a broadcast technology. Anything that we send on a particular medium using Ethernet is in the form of a broadcast. And students, when we have a broadcast technology, we need to have some sort of MAC sublayer type access method that we need to employ before any station can send its data on the shared medium. Students, मैंने आपको बताया था कि in the case of Ethernet, the access method that we use is CSMA-CD, or carrier sense multiple access with collision detection. And the persistent methods that we talked about, in this particular case, Ethernet uses the one persistent method, the simplest of all. तो स्टूडेंट्स, CSMA-CD के केस में जैसा कि आप लोग ऑलरेडी जानते हैं, every single station, before it sends or throws anything on a shared medium in the form of a broadcast, has to sense the medium, has to sense the shared medium before it can send anything. It has to make sure that the medium is idle. There is no positive pulse that actually depicts the existence of data on that network or the shared medium exists. And once this medium is idle for a certain amount of time, only then this particular station is able to send the data to avoid any collisions on that network. Students, let's go on to the next slide, and I'll show you how CSMA-CD using one persistent method uses this particular access technique in the case of Ethernet. Now, students, as you can see, we are going to assume that in this particular case, our station A, once again, has a frame that it needs to send to station D. So your A is your source, and in this case, D is your destination. Now, students, first step is before sending, station A will actually check or sense the medium carrier sense. CD, and this first part of this is carrier sense. So station A will actually sense the medium before it sends anything. And what it essentially does is that it measures the level of energy on the medium. So your carrier sense is actually measuring the energy on the medium. And this is done for at least 100 microseconds. Now, if there is no pulse on the medium for at least 100 microseconds, then A will interpret that there is no data on the medium, that it's an idle medium, and once the medium is detected to be idle, the data is transmitted. Students, on the other hand, I gave you a concept of the back off as well. So if there is some sort of signal energy that is sensed on the network, if it's not zero, it means that the medium is being used by another station, and station A will carry on monitoring the medium until it becomes idle for 100 microseconds, and then it will start transmitting the frame. Students, station A will keep a copy of the frame with itself until it's sure that the frame has been received by the destination without any collisions. Now, students, once the medium sensing has started, once the medium sensing is all good and the medium is idle and station A has already started transmitting the frame, the medium sensing, it does not stop out there. And the reason it does not stop and the reason station A keeps on checking the medium continuously is because of two reasons. The first reason is the station A has sent its frame and no collision is sensed. So the first scenario is the station A that you've got, it sensed the medium for the full duration of frame. And what we found out was that there was no collision. Students, this is our first scenario. The station will be show that the frame has gone through, and it will stop transmitting or send further data if the station is still idle after the frame is completed. Students, the second scenario is that station A senses. It senses a collision, as simple as that. Students, in this second scenario, we know that one of the previous bits has collided with the bit that is sent by another station. Students, both stations will back off. Station A and whatever station that we have collided with, both stations will back off. Both stations will immediately stop from sending any more data onto the link. And in this particular case, station A will send a 48-bit jamming signal. This is called a jam signal on this bus to inform all the other stations that a collision has occurred and the fact that everybody needs to back off. Now, after a while, station A starts sending again. And students, if station A again encounters a collision, the back off time for the second collision will actually be increased exponentially. And for the third collision, it will increase as well. So every single time the station A will encounter a collision, the back off period will be increased.